Greetings, welcome to Mechanical Technology class for today. The class for today will be dealing with the beam, with the UDL, the uniform beam, and with the UDL. In mechanical technology, the beam is one of the short questions in the final exam, and it's one of the straight questions that any learner should get. So, what is a beam? What we'll be talking about? What is a UDL? How to calculate equivalent point load? How do we analyze the point? How do we see the UDL? How do we see the beam? And all that. And then how do we differentiate the overall length and the length of the UDL? So let's get to it. So the concept, before you even get, you should know the uniformly distributed load, which is the UDL. You should know the moment. You should know the point load, support reaction, and the equilibrium, of which we have been from the previous grade 10 and the grade 11. These are the basics. And then the introduction, what is a beam? If you know at least that the beam is a structured member that carries a load, at least you know that in everything that you will be doing, you have to calculate something that is in kilonewtons. So in everything that will be dealing with, it has a load. So the loads acting on a beam can be bonded loads or distributed loads. They can be. Then support reaction act upwards to keep the beam in equilibrium. Then uniformly distributed is the UDL. What is the formula to calculate it? The UDL is the load spread over a certain length of a beam. Here there is a length of point A, point B, not necessarily AB. It can be Z and X, depending on the diagram. So here is the formula: UDL times L, which is stands for length. So how to calculate equilibrium on load? Excuse. And then here there is an example that says the diagram below shows uniform beam supported by a point Y and Z. About the point load and uniformly distributed load of 10 kilonewton and per meter exerted on the beam. So first thing first, here you should know, before you even start calculating, you should know how to calculate what? You should know how to calculate EPL. If you know that one, then the rest will follow. And then the act that is acting downwards towards the UDL is 2, and then on this side, on the towards the Y point, it's 6. And then there is the length, which is the overall length, and then there is the length, which is the length of what? Of the flat. And then here the question says that you should there is no question here, but let's say you are asked to calculate what you are asked to calculate what equivalent point load. So the formula to calculate the equivalent point load here is given here. So it's UDL times length times it's UDL times length. Therefore you find your answer in what? So let's calculate here. Sure. Let's write here. So RDL is what? 10 times and the and the length of UDL is 3. So the answer it will be 30 kn. So this is an example. It's just an example here, this one. Anyway, there is no question that is asked, but I was just demonstrating, showing you where is the UDL, here is the UDL, here is the length of the UDL, here is an overall length here. So, and then here is the point 1, point 2, or point 1, or point 2, depending on how you name it. And then these are the points exerted on the UDL. Now let's try to do the subject to the content of the video. Here, the activity says the figure 8.2 indicates uniform point that is supported by vertical point AB, 2 vertical point load, and uniformly distributed load of 16 kN per meter and are exerted onto a beam. Now, the question says that calculate the following 8.2.1. The point load representing the uniformly distributed load. 2 marks. So how to calculate this one? This one is very straightforward because there is absolutely nothing that will give you challenges here. You just say point for UDL. Then how to calculate a point for UDL? Here is our UDL, and then here is our length, which is 5 and 16. So it's just 16 times 5, which gives us 80 kilo. And then the direction, is it upwards or downwards? It is downwards. So this is 2 marks. What was needed here? Let's write it here. It's 80 kN down. We'll need that information. 8.2.2. And then here you are asked to calculate the magnitude of the reaction at point A, and then on 8.2.3 you are asked to calculate the magnitude reaction at point B. Now, how you are going to do this? It is simple. The first thing, since you have calculated the 8.2.1, here is the way that you can do this thing. Just calculate the position of equivalent. So if you find the point or the position of equivalent point first, which is here, it acts here. Let me just demonstrate here. And then this one UDL, and then this one is point A, this one is point B. It's A, it's B, and then this one, and then the position of equivalent point, it will act here. It's acting like this. It's where you find it. So how to calculate it? And remember, the length of UDL here is what? It's 5 meters. So how to calculate it? To calculate the position of equivalent point, you just divide the length of UDL. So it will be just it's just 5 divided by 2, which gives you 2.5 meters. So this side is 2.5, and then this side is also 2.5. You know now. Let's write it here. 2.5, and then this one 2.5 as well. Let's erase this part. Now, since you've got the point of since you've got the position of equivalent point, what it will be the next? To find the reaction support A and the reaction support B. It is simple. Just first calculate the total downward load. How to calculate the total downward load? Here with the arrow, it shows you. The arrow here shows you. The arrow here shows you. So the total downwards is 4.5 plus 9.5 plus 80. So you just add the total. So the total downwards, is equals to 9.5 plus 4.5 plus 80, which gives you 94 kilonewtons. So you know this one. Let's write it here. We need it as well. Kilonewtons. And then what will be the next step now? So the next step again, just calculate it's R at point A plus R at point B, which is equal to 94. This is the same thing. So what is the next now? Just calculate what? The momentum. How to calculate the momentum? Or let's write here. How to calculate the momentum? To calculate the momentum, we just say R at point B into 10.25. 10.25 is an overall distance. Here it is 10.25, all equals to brackets 80. We calculated 80 times 2 5 plus 4.5 times the overall distance, which is this 5 is this one, 4.5 is this one, and the 5 is this one. And then the answer for this side is 2.5, and then this one is RB 10.25. Now we want RB, so let's divide by 10.25. Both sides 10.25. Cancel. And then the R at point B will be 21.71 kilonewtons. So if you know this one, since you know the resultant at point B, it's simple to find that at A, because you will just substitute. So let's just substitute it to find the A. So it's just the given at point A is equal to plus at point B, so equals to the overall, which is equals to 94. Then this one is RA. Then we take the 21 to the other side, which is 94 minus 21.79, which gives us 72.29 kilonewtons. So here are the answers. This one is for A and this one is for B. So answer here is 80 kilonewtons, and answer here for A is 72.29 kilonewtons, and answer here is 21.71 kilonewtons. So that's the question we had. So only this question, there more will come. Otherwise, thank you.